Lecture environment. Okay. Thank you, Tapan Kumar sir, for giving me such a nice opportunity to interact with you. So today's the title of my guest lecture is aerial photography and photogrammetry. So first of all, we studied what are the basic things that were behind the aerial photogrammetry, and how we are going to analyze things with the aerial photograph. So very simple definition of the photogrammetry is nothing but the calculations associated with the aerial photograph. So first of all, we have to consider what is meant by the aerial photograph, what is the procedure to took a aerial photograph, and how we are going to use that aerial photograph for the analysis purpose. So here I am sharing here with two or three PPTs that explaining this entire process. So if anyone have any query regarding to each PPT, kindly ask within the lecture. It is also permitted. So I am going to share my screen here. Okay, sir. Is my PPT is visible to all of you, Tapan sir?
Yes, sir.
Okay, okay. Okay, now I'm going to deliver the lecture. So first of all, we starting with the remote sensing. What is the basic definition of the remote sensing, and how the aerial photography one of the kind of the remote sensing. So here there are two kind of the sensing. As we all know, it is very basic thing. So there is a proximate sensing, and we also known as a remote aerial photography, which is also known as a remote sensing. So proximate sensing in simplified case, what is meant by that? When we obtain the information about any object which is on the earth surface with the help of the physical touch, then it is nothing but the proximate sensing. And remote sensing means what? It is the art and science of collection of information about an object on the earth surface without physical touching to that object. So we also do the remote sensing as a human being. We have the five sensors, and through that five sensors, we also obtaining the images associated with the objects on the Earth surface. For example, when we looking at an object, we collect the information about that object with the help of our eye. So when we do the remote sensing with the help of the eye, that is nothing but the remote sensing. And when we collect the information about the object after touching to that object, that is nothing but the proximate sensing. For example, tasting something, means with the help of the skin or with the help of our tongue, we taste something, either the hot or cold water. We can understand the warmness in the water with the help of the physical contact with the physical contact of our body with the that particular object. That is nothing but the proximate sensing. So it is very basic definition of the remote sensing is that it is nothing but art and science of collection of information. Why it is known as a art and science? Art is nothing but the perceptions of the human beings, how differently we looking at the object, and what is our perception about that object, that needs to be interpreted in the remote sensing. That's why it is known as a art. And why it is science? Science is nothing but the organized knowledge. So we organize the entire knowledge of the remote sensing, and we try to study step by step that particular aspect or the object. So that is nothing but the science. So that's why remote sensing is nothing but the art and science of collection of information. Collection of information about what? About the object on the earth surface without physical touching to that earth, object or the earth surface. So that's why it is the basic definition of the remote sensing, when we obtain information about the object on the earth surface without physical touching to that object. And these are the fundamentals of the remote sensing, very basic things. My focus is over the aerial photography. That's why I'm just try to interpret basic things associated with the remote sensing. So these are the fundamentals or steps included into the study of the remote sensing. So first of all, for the remote sensing purpose, we require remote sensing system. So remote sensing system means what? A satellite, then sensors or computer system, skilled labor force, all these are included into the remote sensing system. And for the remote sensing purpose, especially for the optical remote sensing, we require source of energy. So here, in case of the optical remote sensing, aerial photograph is also kind of the optical remote sensing. So why they were optical remote sensing, I am going to explain it later. So for that optical remote sensing, main source is the energy of the sun or electromagnetic radiation from the sun. So main source of the energy for the optical remote sensing is the sun. So all energy which is radiated from the sun and strike over the earth surface, that hello, hello, huh, okay, okay sir, okay, thank you sir. Can I continue now? Okay sir. So here the source of energy is the sun, and when, as we all know, the radiation from the sun is in the form of the short wave, and radiation from the earth is in the form of the long wave radiation. So the radiation which is interact with the atmosphere and strike over the earth surface, the remaining radiation which is reflected to the space or sent back to the space is in the form of the long wave radiation. So that radiation was captured by the sensor and images were prepared. So it is very clear to all of you that main source of the energy for the optical remote sensing, especially in order to obtain the aerial photograph, is the sun and radiation from the sun. Then how that radiation is in the form of the electromagnetic radiation? Why it is known as the electromagnetic radiation? Because it consists both electric waves and magnetic waves. That's why it is nothing but the electromagnetic radiation. So when this electromagnetic radiation passes through the atmosphere, various kind of the processes were taken place with the atmospheric component, gases, water vapor and dust particle. So the radiation from the sun was absorbed, some part of the radiation was absorbed in the atmosphere, some reflected back to the space, and some scattered into the atmosphere. And due to that scattering, absorption and reflection phenomena, various kind of the atmospheric processes were taken place, and that processes were captured by the sensor. So we have to know what kind of the processes are there and how that process is affecting over the image capturing process. For example, suppose we want to take the photo with the help of the camera or even with the help of the mobile phone, then sometime we require flash, or sometime without the flash we are able to take the photograph. So here we use the flash as our own source of the energy. Means here the flash work as a source of the energy when we throw the flash over the object, and then the reflected energy captured by that particular camera and image were prepared. So as like that same thing was happened in case of the aerial photograph also. The reflected energy from the earth surface or radiated energy from the earth surface were captured by that sensor and images were prepared. So in that process there are different kind of the atmospheric disturbances, and due to that sometime there was an impact on the aerial photography. So generally the cloud free area or cloud free season were chosen in order to obtain the images. So this is very brief in case of the propagation of energy through the atmosphere. Then interaction of the energy with the earth matter, means when energy interact with the earth matter is also have different kind of the object on the particular area. So when we look at the moisture load on soil, if moisture load on soil is there or water is there, then maximum solar radiation was absorbed by that particular area, and very limited proportion of the energy reflected back to the sensor. And that's why these areas were appear in the darker shade in aerial photograph, and very limited portion was appear in the form of the brighter shade. So maximum water areas, especially deep water areas, or the moisture load on soil or waterlogged areas, they appear in the darker shade in the aerial photograph. And when we look at the snow covered areas, maximum energy reflected from the snow covered areas, or when there were the concrete roads or concrete buildings are there, the maximum energy reflected towards the sensor and it was captured by the sensor. That's why most of the brighter shades associated with the urbanized areas or built up areas. So this is very easy to understand. There are three kind of the processes: transmission of energy, then absorption of the energy, and reflection of the energy. Sometime there was a shallow water, and within the shallow water the energy was transmitted, and due to that it appears slightly displaced from its original position because of the transmission process. So first of all we have to know what kind of the processes of the energies were taken place with the various object on the earth surface. Then we are able to interpret the aerial photograph. So these are the basic themes we have to understand. Then platforms and sensors are also playing very important role. Platforms means all kind of the surfaces over which sensors were mounted. For example, sometime the helicopters or the balloons, they were act as a platforms, but in case of the aerial photography, fixed wing aerial photo, for the vertical aerial photograph and oblique aerial photographs, fixed wing aircraft is playing very important role as a platform. So when we look at the platforms are also having different types. On the basis of that we divide images and aerial photographs. So what is the platforms and what are the sensors, we are going to discuss in detail after this explanation. Then we also look at the transmission, reception, and processing of the data. Means how the data was transmitted, how it was received by the sensor, and what kind of the processes were taken place. So sensor is the mechanical device which gather the energy which is reflected from the earth and capture that energy, convert it into a signal that computer can understand, and later on it is again converted into a simple language, means in the form of the image that human being can understand. So first of all energy was converted into a digital form, and that digital form is again converted into the human understandable language, that is in the image form. So aerial photograph, analog aerial photographs, they are in the form of the image which were converted by the sensors and computing processes. So here after that we have to look over the area, and we try to analyze the things with the help of the aerial photograph, because with the help of the terrain, elevation, flying height, the scale of the aerial photograph is given to you, already given to you, and on the basis of the scale and on the basis of the shadow and shape of the object, we are easily able to perform the calculations related to the aerial photograph. So how we are going to perform that calculation, this is the part of the photogrammetry. So these are the basic things how we are going to obtain the aerial photograph or the satellite image. So we already discussed the source of energy, all energy that moves with the velocity of the light in the harmonic wave pattern. and that pattern also have electric field and magnetic field. That's why it is known as the electromagnetic radiation. Then electromagnetic spectrum is also there. What is meant by the electromagnetic spectrum? For our better understanding purpose, we divided solar radiation into various bands. That is nothing but the electromagnetic spectrum. So how we divide, or how we created band on the basis of the wavelength. What is the wavelength of the incoming radiation? What is the frequency of the incoming radiation? And what is the energy of incoming radiation? So, on the basis of the wavelength, frequency, and energy, we divided solar radiation into the different bands, and that is nothing but the electromagnetic spectrum. So, ordering of radiation in simplified case is nothing but the electromagnetic spectrum. Here we divide entire energy with the help of the wavelength, frequency, and energy. Okay. So here, what is meant by the band? A specific wavelength interval. For example, we consider wavelength in between zero point 0.4 micrometer to zero point 0.6 micrometer. So here we only consider a specific wavelength interval. That's why that specific wavelength interval is nothing but a single band. So as like that, for the remote sensing purpose, especially for the optical remote sensing, when we took the aerial photograph, generally we took the three bands: blue, green, and red. So the visible band is generally considered in order to took the aerial photograph. So blue and green band, when we look at the extension of these bands, generally zero point 0.4 micrometer wavelength to the zero point 0.5 micrometer wavelength, there is a blue band, then green band, and red band. It is very basic, and this visible band is used in order to obtain the aerial photographs. Okay. So these are the basic things which not require that much explanation. That's why in brief I'm try to interpreting that particular aspects. So here, on the basis of the wavelength, we are able to interpret that particular area in the electromagnetic spectrum. If there is a shorter wavelength, then automatically higher is the frequency of that particular radiation and higher is the energy. So all the shorter wavelength areas or bands, they are having the higher energy and higher frequency. Okay. So this is the relationship between wavelength, frequency, and energy. So generally when we look at the energy which is radiated from the sun is in the form of the short wave. So why it was in the form of the short wave? Because of the body temperature, surface temperature of the sun and surface temperature of the earth. So when we look at the surface temperature of the sun, which is near about 6000 Kelvin, and surface temperature of the earth, which is near about 300 Kelvin. So there is a various aspects that are behind the formation of the short waves and long wave. One of the reason behind the formation of the short wave and long wave is the surface temperature. Okay. So due to the surface temperature, continuous radiation of the energy from the sun is there, and due to the continuous radiation, there was a formation of the shorter wave. Okay. So shorter wave consists high frequency and high energy. So energy which is radiated from the sun have the higher frequency and higher energy as compared to the earth. So we have to consider that before starting the study of the remote sensing. And when energy interact with the object on the earth surface, then what are the processes that were taken place? Absorption of the radiation, and due to the absorption, very limited energy reflected back to the sensor or radiated back to the sensor, and that's why that portions were appear black in color in case of the aerial photograph or even in the satellite imagery. And when there is a greatest reflection from the object, especially on the frost, when we look at the reflection from the ice covered area, which is the maximum, and that's why they will appear in the brighter shade, because maximum energy reflected back towards the sensor. So these are the things we have to understand. And when we look at the reflection of the energy from any object, there are different objects on the earth surface which have different absorption and reflection capabilities. On the basis of that, we try to understand what kind of the object we are going to capture on the aerial photograph. So we have to know absorption capacities of every object on the earth surface. For example, when we look at the plant leaf, generally, when solar radiation falls over the plant leaf, blue and red radiation were absorbed, and only green and infrared were reflected. That's why even when we look at the plant leaf, it appear green in color to our eyes. Why it was so? Because only green color enter into our eyes. Green is the visible band, which is visible band section is only visible for the human beings. That's why only green color is visible to us. That's why that particular leaf is appear green in color, and blue and red bands were absorbed. So as like that, when we look at the color of our shirts, uh, uh, especially when we look at the shirt, it is appear blue. Why it is appear blue? Because green and red band is absorbed in that particular fabric, and only blue band were reflected, and for our eyes that blue band is visible. That's why this color is appear like a blue. So that's why that colors are not in the object, they were in the solar radiation, and we are only able to see the visible bands, and as like that we are able to look at different colors. Okay, so it is totally based on reflection capacities of the object. So here I'm going to discuss what is difference between major difference between satellite image and aerial photograph. So on the basis of the platform, we try to interpret satellite image and aerial photograph. So when we look at the platforms, there are various platforms: ground borne platforms, airborne, and space borne platforms. So generally the photographs which were taken with the help of the ground borne and airborne platforms are known as a aerial photographs, and when we capture the image with the help of the space borne platform, then that is nothing but the image, satellite image. So on the basis of the platform, where is your platform, that describe what are you are going to collect about the earth surface. Suppose you are capture the aerial photograph, then that is associated with the borne and airborne platform. And when we capture the image with the help of the satellite, means a sensor which is mounted over the satellite act as a platform, and camera is mounted over the satellite. And when we took the aerial photo with the help of a photo from the space with the help of the satellite, then it is nothing but the satellite image. And when we take the photo with the help of the platform which is on the ground or in the air or the atmosphere, then it is nothing but the aerial photograph. So there are different kind of the ground borne platform. Even the remotely triggered photographs, they are also known as a aerial photograph with the help of the residual hill. Suppose there is a hill, and on the hilltop, when we took the aerial photograph of the valley, then it is also the aerial photograph, because from the elevated position we are able to took the photo. So that's why it is also considered as a aerial photograph. Or in ancient period, especially, most of the time pigeons are also used in order to took the aerial photograph. So generally the photographs which are taken with the help of the platform on the ground or the air, that are nothing but the aerial photograph. Airborne, there are various airborne platforms. Sometimes kite is also used as a airborne platform. Balloons are sometimes used as a airborne platforms. Cameras were mounted over the balloon and photographs were taken. As like that, fixed wing aeroplane or the wooden helicopter, or which we call as a drone, they are also considered as a platform in order to capture the aerial photographs. So all these are the platforms. With the help of these platforms, we took the aerial photograph. So what is the basic definition of the aerial photograph? Then it is also the art and science of taking photographs from an elevated position. So from an elevated position means either you are on the ground with the help of the pole or with the help of the residual hill. If you trigger the photo, that is also known as a aerial photo. Or even with the help of the balloon, with the help of the fixed wing aircraft, if you take the photo, then it is also nothing but the aerial photograph. So aerial photographs may be triggered remotely with the help of the remote control. Especially the balloon aerial photography or drone aerial photography is associated with the remote control aerial photography. We have the remote in our hand and we trigger the aerial photograph. Or sometime aerial photograph were triggered automatically, especially fixed wing aircraft photography, where automatic photography, automatically the photographs were triggered when cameras were mounted over the fixed wing aircraft. Then sometime the manually aerial photographs we are also able to trigger. For example, with the help of the residual hill, we took the aerial photograph of the valley that were manually clicked aerial photograph. So as like that, different kind of the aerial photography is there. So on the basis of the axis, on the basis of the places, on the basis of the platforms, how we are going to perform the aerial photography, that define the types of the aerial photograph. So this is the basic definition of the aerial photograph. It is the art and science of taking photographs from an elevated position. So it is very simple to understand. And these are various platforms over which we are able to capture the aerial photographs. So this is the ground borne platform. Generally, for the microwave remote sensing, cherry pickers are used. Here the sensors were mounted, and with the help of that sensors, aerial photographs were taken. Okay, just a minute. So here the sensors were mounted, and this is the cherry picker which is on the ground. So it is the ground borne platform, and photograph taken with the ground borne platform is known as a aerial photograph. So in 1903, first of all, airborne photography was developed by the Julius. So he was the balloonist, and he used the cameras and for the aerial photograph purpose. He mounted the cameras on the chest of the pigeon, and wherever that pigeon was goes, the aerial photographs were triggered. So this was very good example of the aerial photography in ancient period. And at modern era, at this situation, most of the aerial photographs were triggered by Air Force Agency or NRSC or Air Force Agency Calcutta. So they use fixed wing aircraft in order to get the aerial photographs. So at current situation, this type of the photography is very famous one, and most of our aerial photographs are taken with the help of the fixed wing aircraft. Then how the balloons were used, there are three kinds of the balloon: free balloon, tethered balloon, and powered balloon. Free balloons are with the help of these free balloons we are able to capture the aerial photos wherever that balloon was going. Means there was no any kind of the remote control to capture the aerial photograph. But in case of the powered balloon, we have to control that powered balloon, and we are specifically concerned with a particular area. That's why for that purpose we use a powered balloon method. So as like that, with the help of the balloon we are also able to trigger the aerial photography. Sometime wooden aircraft, or especially the drones, they will act as a platforms in order to capture the aerial photographs. So I will move towards the next portion, that is the types of the aerial photographs. So there are various criteria. On the basis of that criteria, we are going to interpret the types of the aerial photograph. The first one is on the basis of the direction of the axis of the camera. When we look at the camera lens, generally there are two axes in case of the every camera lens: optical axis and vertical perpendicular axis. So vertical perpendicular axis is exactly perpendicular to the earth surface, and optical axis move with the lens. Means as we move the lens of the sensor, that optical axis also moving with that particular lens. So optical axis are different and perpendicular axis are different. Perpendicular axis are generally exact perpendicular line over the earth surface. Means when we look at the camera, the nadir point, which we called as a aerial photographs nadir point, is exactly below the lens of the camera. So that's why it creates the perpendicular axis with the ground surface. That's why it is known as a vertical perpendicular axis. And next one, which is the optical axis, which is moved with the lens of the camera. Generally apex angle at the cone of the rays is known as a optical axis. Optical axis associated with the lens of the camera. As we move lens, automatically that optical axis also going to move. So on the basis of that vertical and perpendicular axis, means direction of the camera, there are three major types of the aerial photograph. First one is vertical aerial photograph. So when we look at the vertical aerial photograph, if the optical axis makes an angle of less than 3 degree with the vertical perpendicular axis, if the angle between these two axes, this is the optical axis and this one is the perpendicular axis, and if the angle between these two axes is less than 3 degree, then it is nothing but, then photograph which is captured with the help of this kind of the camera is nothing but the vertical aerial photograph. Okay, so vertical aerial photograph generally have the angle in between the vertical perpendicular axis and optical axis is less than 3 degree. Then we will move towards the oblique aerial photograph. When it is known as oblique, if this angle between the vertical axis and optical axis goes on increases, and it is above 3 but below 8 degrees, 8 degree, angle between vertical and optical axis is below 8 degree but above 3 degree, then the photographs which were taken with the help of this combination is known as a low oblique aerial photograph. This particular image explaining low oblique aerial photograph. Then third one, if this angle between vertical and optical axis is more than 8 degree, if this angle is more than 8 degree, then this photograph is known as a high oblique aerial photograph. In case of the high oblique aerial photograph, sometime horizon is also visible. And why we use that oblique aerial photography and vertical aerial photography? For the photogrammetric purpose, vertical aerial photography plays an important role. And for the analysis purpose, we choose high oblique or low oblique aerial photograph. For example, suppose there was a remote territory and we are unable to reach that territory, So in such case, we use the oblique aerial photography by bending the optical axis of the camera. Okay, so in this way, with the help of the oblique optical aerial photography, we are able to perform analysis over the remote area also. Okay, so each type of the photograph has its own importance. Vertical aerial photography generally considered for the photogrammetry purpose. So most of our photogrammetrical analysis, they were associated with the vertical aerial photographs. Then types of the aerial photograph on the basis of the combination of vertical and oblique aerial photograph, means two oblique lenses sometimes we use in order to capture the area. Sometimes we use vertical and oblique aerial photograph. So there are three kinds of the aerial photographs on the basis of combination of vertical and oblique aerial photography. Convergent aerial photograph. Convergent aerial photograph means when we use two separate oblique camera lenses which were exposed simultaneously, means at the same time, with the help of the two oblique camera lenses, we are taking the photograph of two different areas which are very nearby. So that is nothing but the convergent aerial photography. Especially such kind of the photography is associated with the remote territory, or even the territory which is near to the enemy area. So in order to survey the area that were associated with the enemy, we use such kind of the convergent aerial photography. Or sometime for the 3D viewing, such kind of the photography playing very important role, because shadows are very clearly demarcated with the help of the convergent aerial photographs. Then the next one is trimetrogon aerial photograph. Why it is known as a trimetrogon? Because it required three types of the aerial photographs, two oblique plus one vertical. So with the help of the central camera, we took the vertical aerial photograph by exposing two simultaneous lenses in the oblique form. So two sides of that photographs are oblique one. At the center, we have the vertical aerial photograph. So this is nothing but the trimetrogon aerial photograph. So at the same time, we also know the vertically that particular area, and also the remote area which is nearby to that area, that also be captured with the help of the trimetrogon aerial photograph. Then there is a strip aerial photograph. Most of our standard aerial photographs, they were associated with the strip aerial photograph, because continuous photographs were triggered in one continuous strip. So most of our aerial photograph, vertical aerial photograph, for the analysis purpose, we choose a strip type of the aerial photograph, because continuously we are capturing the images, and that images can be used for the stereo pairing or for the photogrammetric analysis purpose. Okay, so here the strip aerial photographs are very playing very important role in case of analysis purpose, especially when we try to do the photogrammic grammetric analysis. Okay, so this is on the basis of combination of vertical and oblique aerial photographs. Then on the basis of the angle of coverage, either that photograph is the standard angle or normal angle aerial photograph, that we are going to describe. So what is mean by that angle of coverage? Suppose this is the lens of the camera, and when we look at the cone of the rays which is passing through the frontal nodal point of that particular lens. So frontal nodal point is here. From that point, the solar that particular rays of the optical source, means whichever is the source, either the flash or own source used by that camera, they're having their own angle. So the cone of the rays of that particular angle of that particular camera is known as a apex angle. So apex angle means what? The angle which is formed in between the cone of the rays of that particular camera. So that apex angle decide which kind of the photograph we are going to take. So if the apex angle is 60-degree, that 60-degree angle generally associated with the normal coverage, which we call as a standard aerial photograph, which are 23 by 23 or 70 by 73 vertical photographs. They are generally the normal angle aerial photographs. The instantaneous field of view is covered with the help of these standard angle aerial photographs, are nothing but the standard aerial photograph. So that's why the area which we are going to survey with the help of the exact vertical standard aerial photographs are the 23 by 23 or 70 by 70, which are known as the standard angle aerial photographs. Generally, the apex angle of the cone of the rays is 60-degree. And if that angle was widened, in order to capture the maximum instantaneous field of view. That angle is 90 degree. Then super wide angle 120 degree. To some extent, when we try to increase our coverage, we increase the cone of the rays, and if cone of the rays increases, that instantaneous field of view also going to increase. So generally, for the analysis purpose or for the photogrammetry purpose, we use the standard angle or the normal angle aerial photograph. Okay, so most of our aerial photograph we use for the photogrammetry purpose are of the normal angle 60 degree or the standard angle aerial photograph. Okay, so, and on the basis of the apex angle of cone of the rays, there are also the types of the aerial photograph: standard or normal aerial photograph, wide angle, super wide angle, or narrow angle aerial photographs. Okay. Then, on the basis of the film used, what kind of the film we use in order to capture the satellite image, that also describe the type of the aerial photograph. So, there first, when we look at the first type, black and white aerial photographs are there. So in case of the black and white aerial photograph, generally we use all the bands, means all the visible bands, blue, green, and red. All are the visible bands. Generally we use for the aerial photography purpose. So here for the black and white aerial photograph, when we capture all these three bands, blue band, green band, and red band, and combine into a aerial photography and represented with the help of the gray shade, then it is nothing but the panchromatic aerial photographs. So, which are the panchromatic aerial? Pan means all. Okay, chromatic means color. Means we use all areas and colors in order to capture that particular area or the image of that area. Blue, green, and red. All three bands, visible bands, were used, and they were represented with the help of the gray shades. That's why they were known as a panchromatic aerial photograph. Black and white panchromatic aerial photograph. So most of the photographs given to you for the interpretation purpose, they are the panchromatic, because blue, green, and red bands were used, and all the true colors were represented with the help of the gray shades. That's why they were known as a panchromatic aerial photograph. Okay, so aerial photograph generally used for the photogrammetry purpose or for the analysis purpose, generally standard angle panchromatic black and white aerial photograph. Okay, then monochromatic aerial photograph. Monochromatic means a single color band. Single color band is used. Remaining two bands were filtered by the sensors, and with the help of single color band, we prepare the image. But that single color were represented. A single color was represented with the help of the grayscale. Then it is nothing but the monochromatic black and white aerial photograph. And orthochromatic means two bands were used and one was filtered. Okay, two bands were used in order to capture the photograph and one band was filtered. That is nothing but the orthochromatic aerial photograph. Okay, so in this way, on the basis of the film use, what kind of the film we use in order to filter the color bands, that define the types of the aerial photograph. Then second is color photographs. Means here all three bands, blue, green, and red, were captured by the sensor and represented with the help of its true color. Then it is nothing but the true color aerial photograph. Means generally the photographs taken with our mobile or the flash camera, they are the true color aerial photographs, because we use true colors. Means green were represented with the help of the green, red is represented with the help of the red color. Means we use true color in order to represent these bands. That's why it is nothing but the true color aerial photograph. Okay, then there is a infrared black and white aerial photograph. So infrared black and white aerial photograph means generally blue band is avoided or filtered, and instead of the blue band we use infrared band. So here green, red, and infrared band. Why we avoid the blue? Because when we look at the atmospheric scattering, atmospheric scattering was associated with the blue band, and that's why sky appear blue. So in order to avoid the blueness into the aerial photograph, we avoid the blue band, and that's why instead of the blue we added the infrared band. Okay, so when we use a green, red, and infrared band to capture the aerial photograph, and all these bands were represented with the help of the gray shades, then it is nothing but the infrared black and white aerial photograph. Okay, why it is infrared black and white aerial photograph? Because we added infrared band to capture the photograph. Okay, and with the help of the infrared band, vegetation is very efficiently represented. Then there is an infrared false color composite image. Infrared false color composite means green, red, and infrared bands were used, but they were not represented with the help of the gray shade. Instead of the gray shade, we use a false color. Means green, red, and infrared bands are there. And green is represented by the blue, red is represented by the green, and infrared is represented by the red. So in this way, we use a false color in order to represent the color bands. That's why it is nothing but the infrared false color composite aerial photograph or satellite image. So these are the types on the basis of film use. Means what kind of the film we use, what are the colors filtered by that film, that define types of the aerial photograph. So generally, panchromatic black and white aerial photographs were used for the interpretation purpose and for the photogrammetric purpose. Monocolor and orthocolor have its own significance. For example, only for the vegetation analysis purpose, we use infrared band and we prepare the aerial photograph. So each and every band has its own characteristics, and on the basis of the applications we choose which are the bands that we are going to filter. Okay. So on the basis of the film use, there are these types of the aerial photographs. So this is the standard angle vertical aerial photograph. Why it is vertical? Because the angle between optical and vertical perpendicular axis was below 3 degrees Celsius. Okay, 3 degrees. Sorry, 3 degree. And when we look at the cone of the rays are also a standard angle. Means a 60-degree cone of the rays are there. That's why it is exactly vertical aerial photograph. And why it is the standard aerial photograph? Because cone of the rays is 60-degree. And beside that, when we look at the various aspects in the image, it is the panchromatic, because all these three, blue, green, red, and even infrared bands sometime be used in order to capture the aerial photograph. Because here when we look at the water bodies, vegetation, and open areas, all areas were represented with the help of the grayscale, and they were uh, also well captured with the help of these three bands. That's why it is the panchromatic aerial photograph, because three bands were used and represented with the help of the standard size. Okay. So that when we look at these aerial photographs, what are the things that were easily visible? Generally, the barren lands or the lateritic plateau where the reflection is very high, that reflected high reflectance areas, they were represented with the help of the brighter shade, because the maximum solar radiation which is strike over that particular area reflected back to the sensor, and it was very clearly visible to us. And most of the area which were waterlogged areas or moisture laden soil, or the water is also there, if the greater absorption is there, then automatically very less reflection towards the camera or the sensor, and that object is appear in black shade or darker shade. So most of the water bodies here, they will appear in the darker shade because greatest absorption is there. Okay. So how the shades were prepared, I think you all understood, and how the aerial photographs were described with the help of the film use, and on the basis of the angle of the coverage, we are going to describe here. Okay. Now I'll move towards the indexing of the aerial photograph. So when we look at the indexing, there are various aspects that were associated with the indexing of the aerial photographs. Scale of the aerial photograph is given. Beside that, the level, at what stability level that photograph were taken. Means either fixed wing aircrafts were taken, used in order to take that photograph. Means fluctuation into the flight is also given here with the help of the leveling. And here the number was given, that number describe the job number. This 346 describe the job number, then this 26 describe the strip number, that 3 describe the photo number. So what is that strip number, job number, photo number, I'm going to describe here. Then flying height is also given. Means which elevation that aircraft is there, that described with the help of the flying height. Then photo number is also given. Even clock is also given here, at what time that photograph was taken, that also described on the aerial photograph. So we are able to read all these things when we look at the indexing of the aerial photograph. And the indexing of the aerial photograph sometimes playing very important role when we do the photogrammetry. So this is all about that numbers given at the right hand corner of the aerial photograph, which we called as the indexing of the aerial photograph. So here that first number describing job number or the task number. So during what job that photographs were taken, described by that job number. Then strip number means at what line that photograph is taken, that describe the strip number or the run number. Then there is a photo number, in which strip, at what number that photograph is there. that describe the photo number. So with the help of this that particular diagram, I'm going to describe that. This is that diagram which describing the specific task. Suppose our task is to cover that entire area. So for that entire area, one job number was assigned at a particular time. So for that entire area, suppose the job number or the task number was the one. Okay, then the indexing was doing as like we do indexing as like that. Here we wrote the task number. Then this one is the task number. Then in that particular task, number of the strips are there. Within one strip, it is impossible to cover the entire area. So this one is the first strip. Then again, aircraft move like this way, and this one is the second strip. So this is the first strip, this is the second strip, this is the third strip. As like that, strip numbers were given. So this is suppose we try to interpret the indexing of this aerial photograph and this strip. So this is the first strip in that particular task, first job, and from that first job, this one is the first strip, and from the first strip, this one is the fourth number aerial photograph. First, second, third, and fourth number aerial photograph. So that's why aerial photograph number is also given. So this is the job number, then this is the strip number. In the first strip, fourth number aerial photograph is taken for the analysis purpose. And here again, one number alphabet was given, that alphabet explaining what kind of the agency is there which took that aerial photograph. Three important agencies are there: Air Force, NRAC, and Air Survey Company, Calcutta. They took the aerial photographs, and again, on the basis of the agency, we index that particular aerial photograph. So suppose that photograph was taken by the Air Force agency, then we wrote A here. If that photograph was taken by B, means NRAC, then we write B here. So on the basis of that alphabets, we are also able to identify what is the name of that agency which took that aerial photograph. Okay, so this is all about indexing of the aerial photograph. Then I will move towards the next aspect, aerial photogrammetry. For the aerial photogrammetry purpose, we have to know what is nothing but the stereoscopic imaging. Stereoscopic imaging means what? For the stereoscopic vision, we require two images, overlap areas within the two images. Suppose when we took this first strip, in that first strip, some part was overlap over each other. There are two kinds of the overlap: forward lap and end lap, or which we called as a overlap and side lap. So when we took the aerial photograph first and second, then automatically some area which is about 60% was overlap over each other. Without that overlap, we are unable to do the stereoscopic imaging. That's why that overlap is playing very important role. So in every stereoscopic imaging or any kind of the photogrammetric observations, we required pair of aerial photograph which contain near about 60% of overlap area. So here the overlap area playing very important role, and sometimes side lab also we choose in order to perform the analysis. So that side lab is near about 30%. So near about 60% of overlap forward lab we required in order to prepare the stereoscopic imagination. And stereoscopic imagination playing very important role in the photogrammetry. Okay, so I think you all know how we perform the stereoscopic analysis. Means for the stereoscopic analysis, we required pair of the aerial photograph. We required 60% of the overlap area, and that 60% of the overlap area, we are able to see the 3D viewing. Means 3D views were associated with the overlapping of the areas. Even our eyes are also having the stereoscopic imagination. Suppose we are looking at a particular object with the help of the single eye, then it is impossible to perform the stereoscopic operations because the depth is not that much visible with the help of the single eye. If we look at particular object with the help of our both eye, then automatically stereoscopic image or vision was created, and we are able to see the depth. So same principle was followed in order to perform the stereoscopic operations with the help of the satellite images. For that purpose, we required at least 60% of the overlap area for the stereoscopic imagination purpose. Okay, so I think it is clear to all of you. Now I'll move towards the geometry of the aerial camera or aerial photography. Means how that camera work, what is the lens plane, that were well described with the help of this diagram. Understanding of this diagram is playing very important role when we are doing the aerial photogrammetry. For the calculation purpose, we have very good understanding regarding to that particular image. So that describe the lens, that particular image describe lens of the camera, and what is the distance between lens of the camera and negative plane, and distance between lens of the camera and positive plane. So there are two planes, negative planes and positive planes. Negative planes captured image negatively, means in inverted proportion images were captured. That's why this area is known as a negative plane. And again, we prepare with the help of the lab the positive image of that particular negative plane. That's why this is the positive plane. So there is the camera and this is the lens. And after the lens, when we look at the lens also have the positive and negative plane, and all the images or data is captured on the negative plane in the form of the negative view of that particular image. Okay, so distance between the negative plane and the lens, or distance between the positive plane and the lens, is nothing but the focal length of that particular camera. Okay, so that focal length also describe what is the view covered by that particular camera, means instantaneous field of view coverage of the camera is also depends on focal length of the camera. If focal length decide what is the instantaneous field of view of that particular camera. So I think you all understood what is meant by the focal length. Focal length is the distance between negative plane and the lens of the camera, or the positive plane and lens of the camera, known as a focal length. Okay, then the instantaneous field of view means the terrain view covered by that particular camera is nothing but the instantaneous field of view, means what is the image we are going to capture with the help of the camera, defined as an instantaneous field of view. So this is on the terrain. So beneath the terrain there is a sea level. From the sea level to the terrain surfaces, what is the height that describe the height of that particular terrain. So here terrain height is also sometimes playing a very important role, because from the surface to the sea level, we consider that height as a terrain height or terrain elevation. Then the from the surface of the earth surface to the lens of the camera, means the distance between the platform. Suppose camera lens is here, means what, the platform is also here. So distance between platform and the surface of the earth or the object is nothing but the flying height. So this is the flying height, which is generally represented by the capital H. Terrain height represented by the small h for the photogrammetric observation. Focal length is represented by the small f. As like that, these are the various aspects which were playing very important role when we are doing photogrammetry. So again, it was well described with the help of this diagram. Vertical aerial photograph, in case of the oblique aerial photographs, what kind of the optical differences are there, that were well described with the help of this diagram. And this picture define the stereoscopic vision test, means with the help of the pocket or mirror stereoscope we are able to perform the stereoscopic vision, means 3D visions can easily be prepared with the help of this diagram, which were included in your practical syllabus. So I think this is associated with, hello, this is associated with basics of the aerial photography and types of the aerial photograph. So can I move towards the photogrammetric calculations associated with the aerial photography? Tapan sir? Okay, okay, sir. Okay. So I'm continuing here with elements of aerial photo interpretation. What is the difference between oblique and vertical aerial photograph in brief, and later on I move towards the photogrammetry. Okay, so this is the vertical aerial photograph, which is exactly vertical, means distance between the vertical perpendicular axis and optical axis is below 3 degree. That's why it is vertical. Then this is the oblique aerial photograph. It is again associated with the angle of coverage and direction of the axis. So it is the low oblique aerial photograph. And what is the benefit of the low oblique aerial photograph? The benefit is that shadows were easily visible, and with the help of the shadows we are able to identify depth of that particular object. Means here is the bridge, or the road is there, or water is there, that can be easily interpreted with the help of the oblique aerial photograph. If it is vertical, then shadows are not that much visible, and if shadows are not that much visible, then we are unable to interpret the depth of that particular object or height of that particular object. So sometime in order to identify depth and height of the object, oblique aerial photograph playing very important role. Then this is high oblique aerial photograph. These are the catchment areas of dam, and which were not that much easily accessible. That's why oblique aerial photography is used in order to capture that remote areas. So sometime oblique aerial photography, high oblique aerial photography playing very important role in order to capture the remote areas, images of the remote areas. So these are the basic elements of aerial photo interpretation. What are the things that we have to consider? What is our perception about the objects on the Earth surface? That are also playing very important role when we try to interpret the objects on the Earth surface. So here, this is the car parking area. On the basis of the size of that particular object, we are easily able to recognize these are the cars. In second picture, railway tracks are there. On the basis of the size, how they were arranged, that define there are the railway tracks. So sometimes our cognitive imagination or perception playing very important role in order to interpret the images. So here, with the help of the specific shape, aeroplane has a specific shape. On the basis of the shape, we are easily recognize that there is a aeroplane. So sometimes a specific this third image is associated with the Pentagon. Pentagon building is also having very specific shape, which is very unique in the bird. That's why we are easily able to recognize that this building is the Pentagon. So sometimes specific shape also playing very important role when we try to recognize the object. Okay. Then texture means variation into the tone. Sometime also define what kind of the object is there. Suppose there is a pastured land, or suppose this one is the debris of the sometime bamboos, or especially the cash crop like sugarcane. So this kind of the things were associated with the textures to identify what kind of the crops are there. Either vegetations are very plant one, or they were scattered over entire space. They can be easily identified with the help of the texture. Okay, then pattern. A specific pattern also able to interpret what kind of the features are there. For example, with the help of these patterns, we identify these are the aeroplanes, but they were remain stable over the space. So sometime this is the graveyard of the planes. Means planes generally which required much kind of the work in order to became became in the working position. So sometimes this is the graveyard. We are easily identified what is the position of that particular objects on the ground surface. So sometimes pattern also defined. Delta region is also easily identified with the help of the pattern. Means what kind of the pattern created by the river define what kind of the region is that. So sometimes patterns are also playing very important role to identify the object. So we have to know what is meant by the pattern, and how with the help of the pattern we are going to describe the things. So here, this first image is also very interpretive. How the shadows are playing very important role in order to identify object were well interpreted with the help of the first image. Without the shadow it is impossible. Some Just a minute. Without the shadow it is impossible to identify the human beings which were standing here, because only the heads of that particular human beings were visible to us in the form of the spots. If shadows are not there, then we are unable to recognize they are the human beings. Okay, so with the help of the shadows, sometimes some objects were easily visible. For example, here two roads are there, but in between these two roads there is a overbridge. So overbridge can easily be recognized if shadow is there. So sometime oblique aerial photograph with the shadow playing very important role to identify the object on the Earth surface, because we are not that much familiar with the views in the aerial photograph, because we are looking horizontally to the bird, and aerial photograph looking vertically to the objects on the Earth surface. So that's why sometimes it is very difficult to recognize object on the Earth surface. If shadow is there, then it is very easy to recognize the object. That's why shadow is also playing very important role. Then height and depth perception can also be done with the help of the aerial photograph. Then association, sometime these are the buildings near to the water areas, and they have the chimneys. So on the basis of that, we are easily identify that this is the industrial site, because it is formed near to the water bodies, and chimneys are also there. So on the basis of the specific characteristics, we are able to identify what kind of the object is there. So sometimes situation of that particular object, site of that particular object where it was formed, and association near to that particular object. What are the areas? Sometime it also playing very important role to identify the object on the earth surface. So site, situation, and association also playing very important role. Okay, so these are the basic things that were associated with the aerial photography, types of the aerial photography. And in case of the aerial photogrammetry, we already studied that on the basis of the film used, there are black and white true color aerial photograph and false color composite infrared aerial photograph. So this is the normal aerial photograph, true color aerial photograph, and with the green shade. This one is the true color, normal color aerial photograph, and this one is the false color composite, because infrared radiation were captured and it was represented with the help of the red color. So in this way, sometime infrared radiation playing very important role in order to identify the vegetation. This is the satellite image of the Karvir Tahsil, and most of the areas which were represented with the help of the red shade, they were the vegetation covered areas, and water bodies are in the dark shade because of the greatest absorption, and cyan color is for the settlements. Okay, so in this way, in the false color, we also have the different colors to represent the different objects. Okay, so this is all about the elements of the aerial photo interpretation. Now I'll move towards the last slide, which is associated with the calculation of the scale, means photogrammetric analysis. So in case of the photogrammetric analysis, we are able to calculate the height of the object, scale of the aerial photograph, or a scale of the that particular topographical map. So anything which is associated with the aerial photograph can be calculated if we have the proper vertical aerial photographic image with the index numbers. Okay, so if we know the indexation, we know the scale of the aerial photograph, then we are able to calculate the object of the height of the object, or even the depth of that particular valley in the aerial photograph. Even by calculating the shadow over that aerial photograph, we are able to calculate the scale of the aerial photograph. So basic things are there, we are going to study with the help of this particular exercise. So in case of the aerial photogrammetry, our first exercise is determination of the scale. We are able to determine the scale if we know the photo distance and ground distance. Okay, photo distance means what? The distance between any 2 points on the photograph is known, and if the corresponding distance between the 2 points on the ground is known, then we are able to calculate the scale of the aerial photograph. Okay, so this is our first exercise to calculate the scale of the photograph. If the distance between photo means, suppose this one is the aerial photograph, and if we want to know the distance between these 2 points, okay, then distance can be easily calculated with the help of the scale of the aerial photograph. But if we want to calculate the scale of the aerial photograph, we don't know the scale of the aerial photograph, then we require photo distance and ground distance. So photo distance means what? When we took any 2 points on the photo and we know the distance between these 2 points, and corresponding distance of these same 2 points on the ground is known, then we are able to calculate scale of the aerial photograph. So here one question was asked in examination. The distance between 2 points is measured on the ground is 1000 meter. So on the ground, the distance between point A and point B is 1000 meter. Okay, and the distance between same 2 points on the aerial photograph is 1 centimeter. So on aerial photograph, distance between these 2 points is 1 centimeter. So we know the ground distance, we know the photo distance, then it is easy to calculate the scale of the vertical aerial photograph. So what is the formula then? The scale of the vertical aerial photograph is equal to, yes, is equal to d, small d upon capital D. So here d is the, small d is the distance on the aerial photograph, capital D representing distance on the ground. So here distance on the aerial photograph is given 1 centimeter, distance on the ground is given 1000 meter. So we have to change the units, and we have to perform the activities, all the activities associated with the computation is when the units are same. Okay, so we have to perform all the activities by converting meter into a centimeter. Hello, meter into the centimeter. That's why we convert this 1000 meter on the ground into a centimeter by multiplying the 100 Why we are multiplying 100? Because 100 centimeter is equal to 1 meter. So that's why we have to convert that meter into a centimeter. So in this way, scale of the aerial photograph is 1 centimeter divided by 1 lakh centimeter. Okay, so automatically we get the similar figures. 1 centimeter is equal to 1 lakh centimeter. So scale of that aerial photograph is 1 as to 1 lakh centimeter. Okay, it is very easy to calculate. Means 1 centimeter on the map representing 1 lakh centimeter on the ground. So this is the scale of the aerial photograph. So in this way, we are able to calculate the scale. We are able to calculate the photo distance, even the distance on the ground, with the help of the photogrammetry. So this is one of the example which is used in order to calculate the scale of the aerial photograph. Then, and this is the second category. Suppose we have the photo distance and the map distance. Instead of the ground, we have the map. This is the aerial photograph, and this one is the map of that particular area. And we know the distance between 2 point on the aerial photograph and distance between 2 point on the map. And if we have these two distance on the map and on the aerial photograph, then also we are able to calculate the scale of the map. So here the photo scale and map scale was given to you, and on the basis of that, we are going to calculate the scale of the map. Okay, scale of the aerial photograph. Okay, so here the photo distance divided by map distance multiplied by the scale of the map. So if scale of the map is known, photo distance or map distance is known, then we are able to calculate the scale of vertical aerial photograph. So 5.2 inches is the photo distance. Then 3.05 inch is the map distance. Okay, then we have to convert that into a scale. So how we are converting that into a scale? By multiplying the scale of the map. So we multiply these figures by the scale of the map, then automatically we get 1.5 inch representing 76,000 inch on the ground. So we have to convert it into a one, because we have to find out what is for the 1 inch instead of the 5.2 inch. So here a scale is representing only for the 5.2 inch, so we have to convert it into a 1 inch. So here when we follow the simple procedure, for the 5.2, 76,000 is there. Then for 1 inch, what is the scale? So by performing these simple steps, 1 divided by 5.2 multiplied by 76,000, we get the scale for 1 inch. So for 1 inch, 14,663 inch is the distance on the ground, and this is the scale of the map. Okay, so these are the two methods. If we know the photo distance and ground distance, if you know the photo distance and the map distance, then we are able to calculate the scale of the aerial photograph. Hello, hello. Okay, okay, sir. Actually, I only have these two kind of the examples. It required much more time to explain every aspect associated with the photogrammetry. That's why I only choose these two examples to calculate the scale of the. If anyone have the questions regarding that.
Sir, please tell me about little bit proximate sensors.
Okay, proximate sensing means what? When we obtain information about any object with the help of the physical contact. Means, suppose we want to know the temperature of the water. We touch that water and identify it is hot or cold. So that is nothing but the proximate sensing. Proximate sensing means what? When we obtain information with the help of physical touch. Okay, so there are so many proximate sensors. When we look at the thermometer is the proximate sensor. When we dip that thermometer into water, we get the temperature of the water. Okay, as like that, proximate sensing is nothing but we obtain the information about the object after physical touching to that object. Okay.
Okay.
Okay. Okay, sir. Okay, okay, sir. No problem. Thank, thank you, sir. Thank, thank you. Thank you so much. Can I log out now? Okay, thank, thank.
স্যার স্যার বলছিলাম এখানে একটু ল্যাঙ্গুয়েজ প্রবলেম হয় আমার বিশেষত। তো সেখানে আমি চাইছিলাম গতদিন স্যার যেভাবে বাংলায় ক্লাস নিলেন এবং অবশ্যই ইংরাজিতে আমাদের বোঝার চেষ্টা করতে হবে। কিন্তু যখন আমি YouTube চ্যানেলগুলো দেখি একটু সময় লাগে গেস করতে, হয়তো সরাসরি আমি কোয়েশ্চেন করতে পারি না। তো সেগুলো আমাকে বারবার দেখে তবে এটা রপ্ত করতে হয়। তো যদি বাংলাতে একটু হতো সেটা সুবিধা হতো।
স্যার আমারও স্যার আমারও ওই একই প্রবলেম।
ওয়েলকাম স্যার।